This is Monday, January 12th, Algebra 2, 5th period with Miss Steinbach. We are on page 233.
Good job.
Thanks. Where it says dividing polynomials. And we're in the middle of the page. It's probably like A or B, Stormy. Is it A or B?
It's B at the very top.
Perfect. B,
Long division.
where it says using long division. So, before you got here, Stormy, I retaught Ella and Josiah how to do it with numbers, and I hope that helps you. So, in lesson 5-1, you learned to divide monomials, because remember that was just reducing all the terms. You can divide a polynomial by a monomial by using those same skills. So again, x squared divided by x is what?
X to the third.
Nope, that would be multiply. What's divided?
Oh, no. X to the first.
Right, correct. So these same skills where you would reduce powers and things like that are what you need in this section. So for the first example, it just gives us an idea of what long division is. Not how to do it, but what it is. So check it out where it says divide a polynomial by a monomial. Simplify. Okay, who's ready to read this thing? It's 4x cubed y squared plus 8x y squared minus 12x squared y cubed all over 4xy.
Wow.
Yeah, nasty, right? But remember, with the tricks of the trade that we learned, we can separate. How many terms are in this polynomial on the top in the numerator? 3. So you can separate these 3 terms out and divide each of them separately by 4xy. So see, Stormy, on the next line down, where they write the whole thing again, and there's an equal sign? They separated out all the terms. They said, okay, we can do it this way. We could say 4x cubed y squared over 4xy, because that was the original denominator, plus, then the next term, 8xy squared over 4xy, same denominator, and then a minus sign, 12x squared y cubed over 4xy. So then you could just do all those separately. Whew. I think that's way easier to handle than that big monster, huh? So let's think about this. How do we reduce the first one? 4x cubed y squared over 4xy. Let's reduce the numbers. 4 divided by 4 is 1. X cubed over x.
X to the second.
Correct. And y squared over y.
Y to the first.
Yep. So your first term that you simplified out of the 3, this is x squared y, because the numbers go away. That doesn't seem so scary when you separate it. Let's try the next term where it says 8xy squared over 4xy. Numbers first. 8 over 4 is 2.
2.
X and x. They
1.
just cancel, right? It's just 1, right? Y squared over y. Y. So your next term,
Y.
yeah, your next term is 2y, a plus 2y. So far, you've simplified it to x squared y plus 2y. Now, last but not least, the term after the minus sign, 12x squared y cubed over 4xy. So same principle, 12 over 4, 3.
3.
X squared over x, x. And y cubed over y. Y squared. That's right. So that's minus 3xy squared. So the very last line of the example gives you your answer. Each term. X squared y plus 2y minus 3x squared. Or excuse me, 3xy squared. That's the easiest thing in this whole section. Okay? That is why long division works. You can separate just like that. But that was a monomial. We're going to learn how to do it with the... So Stormy, for this example too, I would like you to just read and follow along, and you too, Jessica, when you're reading through this. And keep with us. We're going to talk print for a while. But it's very important that you at least have an idea of how this works. All right. You can use a process similar to long division to divide a polynomial by a polynomial with more than one term. Obviously, it has to be more than one term if it's a polynomial. Silly book. Okay. The process is known as the division algorithm. Who's seen that word algorithm before? Anybody know what an algorithm is? It's basically a math recipe. It tells you how to do stuff. Like, for instance, the Pythagorean theorem is sort of an algorithm. You plug in A and B and you'll get C. Does that make sense? Those are algorithms, things you follow to get an answer. So, when doing division, remember that you can only add or subtract like terms. Hint, hint, wink, wink, nudge, nudge. Okay? Like terms. You can't add 4 plus x. That doesn't make any sense because we don't know what that is. All right. Okay. Who's ready to jump in? Okay. Z minus 4. Okay. Do you see the Braille, Stormy, after it says use long division to find? Open paren x squared plus, or z squared plus 2z minus 24 divided by z minus 4. Looks really scary, doesn't it?
Yes.
Okay, right below there, do you see how they set it up? They should have given you z minus 4 and then an O, right? So, print people, what's the dividend? No. Ella? What's the dividend? Right, the one inside the thing. The divisor is the one outside. Okay. So, you're used to seeing this number out there. Like, for instance, 15. We have a z minus 4. So let me ask you this. How many times does z go into z squared?
2.
No? Like if you were to divide z squared by z, what would you get?
Z.
Right. So you put the z on top in print, and in Braille you would, well, they don't really have a way of teaching long division in Braille, which is kind of sad, actually. Maybe I'll come up with one.
No, it's just kind of scattered. It's weird.
It is. But yes, it's z. You're right, Stormy. And you can still answer my question. You guys see that? Z into 2z squared is z.
What is the z called?
I mean, the one on the top?
Yeah.
That's the quotient. The answer. Okay. So we just divided. Now we have to multiply, folks. So what's z times z? Z squared. And what's negative 4 times z? You have to multiply both terms.
Negative 4z.
Correct. So below the z squared minus or plus 2z, you would write minus, because we're subtracting now in print, z squared minus 4z. You see where I got z squared minus 4z? Print people. Print people. Yes, no. You have to be loud because this is for YouTube. Oh, yeah. Okay. Okay, so now we subtract. What's z squared minus z squared? 0, right?
Yep.
What's 2z minus negative 4z? 6z. So your 6z should be below the line, and you bring down the negative 24, just like in long division. All right. How many times, and we start again, z go into 6z? Right, 6 times. So you can always check yourself. You can say, is 6 times z 6z? Yeah, sure. So then, up above, next to your z, you put plus 6. Okay. Here we go. Then we're going to subtract. So if you look to the right, people, that's where we're at. Z times 6 is 6z. And negative 4 times 6 is?
Negative 24.
Right. So after we did the multiply, we subtract again. 6z minus 6z. Nothing. Negative 24 minus negative 24. 0.
Yep.
Your answer is z plus 6. How do you feel about that?
Yeah.
Yeah,
Kinda tricky.
it is tricky. It's tricky for print, definitely tricky for Braille. What do you think, Josiah?
Okay, so you multiply what's on the outside
By what's on top.
Okay.
Right. But you only check the z part. You say, how many times does z go into z squared? You say z. And then you do all the subtraction. And you say, how many times does z go into 6z? Goes in plus 6 times. And then you multiply and subtract. Oh, not too scary, right? A little.
Yeah.
It's just getting used to the fact that you only look at the first thing, the z part. All right, let's turn the page. All right. Here's a multiple choice one. It's just one with a remainder. But it's still the same process. I just kind of want to talk you through it. So Stormy, we're going to talk through it real quick. It's a test practice where you have which expression is the quotient, or is equal to this, t squared plus 3t minus 9. Oh, times, what do we do with the 5 minus t to the negative 1? This is a tricky one. How would we set this up? What does 5 minus t to the negative 1 mean? Anybody know? What is, because you know what the first one is, but what's 5 minus t in parens to the negative 1 mean? Huh?
What was it?
Open paren 5 minus t to the negative 1. What happens? You guys remember from a couple of sections ago with negative powers? You flip it. He's right. So this expression can be rewritten as a division problem, right?
Mm-hmm.
Squared plus 3t minus 9 all over 5 minus t. Now, here's the thing. I would switch it to negative t plus 5, and that'd be good. Because then it's in the right order. Right? Alright.
Mm-hmm.
So, let's look at this part where it says solve the test item. You see that, Stormy?
Yep.
Alright. They wrote it, and see, look, Josiah, they changed it like I suggested. I didn't even look. Huh! Okay. Negative t plus 5. Alright, Josiah, how do we start? How many times does what go into what? I just want to see if you know it. No pressure here.
Oh, yeah.
We're at solve the test item. So we already wrote it
Yeah.
into the divisor is negative t plus 5. We just switched everything around.
Yeah.
And then inside is t squared plus 3t minus 9. So how do we start the whole division thing? Pretend the answer is right there.
How many times is t given? I think it's t given.
Correct. And how many times does negative t go into t squared? What times negative t is t squared? Negative t. So you put the negative t on top. What's negative t times negative t? T squared. And then what? Right. What's 5 times negative t? Right. So below the t squared. Right, Stormy. Below the t squared plus 3t, you would have negative, or t squared minus 5t. Then we subtract t squared minus t squared. Nothing.
Yep.
3t minus the negative 5t. Right, 8t. Not 80. 8t. All right, Ella, what's the next thing? We just subtracted. Right, we bring the minus 9 down. Yeah, I forgot about that. Then what? Right. How many times does negative t, though, go into 8t?
1. No, 8.
Negative 8. Because remember, it's a negative t and an 8t. So negative 8 times. So up top you have negative t minus 8. Correct. Okay. Now we got the negative 8 up there. Now we multiply. negative t times negative 8. Right, plain old 8t. Because a negative times a negative is a positive. Okay, 5 times negative 8? Negative 40.
Negative 40.
Correct. Now we subtract 8t minus 8t.
Nothing.
Nothing, that's right. Negative 9 minus a negative 40. Right, 31, because you have minus 9 and a positive 40. 31. So that 31 is your remainder, because how many times does negative t go into 30? That doesn't make any sense, does it? There's no way that makes any sense. Then you would rewrite your answer. The answer is negative t plus 8 plus 31 over the divisor, which is 5 minus 2. How do you feel, pretty people? Yeah?
Would it still be correct if you left it at 5 minus, and if you left it at negative t plus 5?
Well, you just have to look at A, B, C, D.
Oh, gotcha.
So,
Okay,
like,
sorry.
you could if there wasn't a multiple choice.
Oh, all right.
You could totally leave it that way. I would accept it.
Okay.
But this case, yeah, just find the one that, because I think they factored out a negative 1. So what's the answer, everybody? A, B, C, or D? C. That's right. All right. Okay. So, great news. There's an easy and fun way to do this.
Yes.
It's called synthetic division. Synthetic division. It sounds classic, right? Synthetic division. It is, now in brainstorming, you'll have to find your own creative way of doing this, but you set it up in a similar fashion to matrices. It is not a matrix, but you're going to space numbers like you would in a matrix. That's just a hint of what's coming.
I'll see how they do it, but yeah.
Well, we will do it synthetically, and I will let you choose. I mean, I'm sure you're going to choose synthetic division, but print users, I want them to do a couple of each for funsies. All right. Use synthetic division. Synthetic division is a simpler, process for dividing a polynomial by a binomial. What's a binomial? 2 terms. You got it. Okay. Suppose you want to divide. Here goes. A nasty one. 5x cubed minus 13x squared plus 10x minus 8 by x minus 2 using long division. Compare the coefficients in your answers. Okay. So in example 4, it's just blah, 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 blah. It looks like it's telling us how to do this. Okay. So the coefficients. Somebody name me the coefficients in this cubic polynomial. In order. We're, sorry, at example 4. I just want to know what all the coefficients are. In order. What's the coefficient mean? Right? Uh-huh. And? That's constant. You count the constant. Okay, 8. And negative 8. Got it. All right. That's right. Those are important, and it's all divided by x minus 2. So the first thing you want to do is write the terms of the dividend so that the degree of the terms are in order. They might not always be in order. In this case, they're in order. Do you know what I mean by in order?
Yeah.
Okay, the biggest exponent first, followed by the next biggest, and so on. Okay, so it's done that. What you would want to do, like I said, is write down the coefficients in a line. So in print, you would write a 5, and in Braille 2, space, negative 13, space, 10, space, negative 8. All in a row, on the same line. Okay?
Okay.
And once you've done that, you've started the setup of the problem. So it says, write the constant r of the dividend, where x minus r is to the left. Okay. So what is our constant of our dividend? Who can tell me? Which one's the dividend? No, that's, I'm sorry. The constant of the divisor. You're right. Ella, you're correct. I'm wrong. What is the constant of the divisor? Oi. Right. But what's the constant? The negative. Right. The negative 2. So next to your line of coefficients on the left, you would write a 2 and make a box. I'm going to talk about that. In Braille, Stormy, you would write the 2 and then a 4, 5, 6. And then all the line of coefficients. We're going to practice. But first, I just want to talk about it.
Okay, good.
You see in print how they have it on the right of the steps? They have all your coefficients in a line, and they have a little 2 in a little angle bracket. You see it? All right. Look on the top of the next page at step 3. All right. Oh, I forgot to mention. Remember the first coefficient was a 5. Do you see the little diagram, Stormy, after step 3?
I'm just gonna look at step 2 real quick.
Okay.
See how many.
So see how they put a 2 and then a 4, 5, 6? And then a
Yeah,
5
and then all the
right.
lines.
And then a blank space. Right? And a line?
Yeah.
So in print and Braille, you would set it up in this way. The first thing you do, after you write all your coefficients and your divisor, the 2, is you switch the sign of the constant. Okay, and you put it in that little angle bracket in print. So since we had a negative 2 in the divisor, we put a 2 in the little angle bracket. Okay? So this is an algorithm, something for you to think on. So the first thing you do is bring down the 5 below the line. The 5 is the very leading coefficient. So Stormy, for you, it should be, did they do a line of 3 5s? A whole bunch of coefficients?
It's just making the steps right now.
Okay.
It just has 2, looks like times 5 or 0.5?
That's right. It's a times sign.
2 times 5.
Right. So what you do is you take
10.
that divisor. Yes, is 10. You take that divisor and multiply it by the first coefficient, which was a 5. So 2 times 5 is 10. And you put the 10 below the negative 13, because the negative 13 was the next coefficient in line. And then you add. What's negative 13 plus 10? Negative 3. Then we start over. Once we get another number below the line, we multiply again. What's 2 times negative 3? Right. And then you put it under your third coefficient, which is the 10. So we're in step 4 right now. What is 10 plus negative 6? 4. Okay, one last go. So you're at the bottom of the line, you multiply again. 2 times 4 is 8. And negative 8 plus 8 is nothing. Okay, so Stormy, look at step 5 and see if you can find our little diagram.
Okay. Okay, I found it.
Tell me what the numbers are on the bottom.
5,
Uh-huh.
3.
How about the negative 3?
Oh, and then they just did it weird. They did the negative sign and then a space and then the 3.
Oh, that's weird. Okay.
So it threw me off.
All right.
And then a 4.
Okay. So you remember 5x cubed. Our polynomial was a cubic. Do you remember?
Mm-hmm.
Well, now you have 3 terms. So this is actually, these 3 numbers, 5, negative 3, and 4, are the coefficients of your answer, believe it or not.
Mm.
But where you start is where your next, excuse me, it was a cubic, So we start our answer x squared. So our answer is 5x squared minus 3x plus 4 with a remainder of nothing. Yep.
Change it to the square?
Well, think about it. Remember when we divided earlier? We said how many times does z go into z squared? It's always z. It's always one less degree than when we started.
Oh.
Does that make sense? So if we had x into x to the fourth, we would say, oh, that's x cubed. And that's always the first start to your answer. So your answer will always start 1 degree less than what you had in the dividend, is the correct answer. So your answer is 5x squared minus 3x plus 4. So Stormy, you and I need to talk logistics.
Yeah, that's kind of tricky.
So for you, I don't really care if you line them up. You may. I want you to find a way that works for you. So all we're doing, and I'll put it in simple terms. First, you figure out what the constant is. If it was x minus 4 as our divisor, 4 would be our constant. So you put your 4 out front. Then you drop your leading coefficient. Then you start your multiply. You multiply your constant by your leading coefficient, add, repeat. Multiply, add, repeat.
Okay.
That's all you do until you run out of numbers. Your last number is always your remainder. So in our case, we had a remainder of 0, so we just ignored it. Okay? And the other numbers to the left of your remainder are your answer. They're the coefficients of your answer. And your answer will always be 1 degree less. 1 degree less. And if you want to look, they did this same problem with the 2. We're going to ignore it. So Stormy, I want to do some practice with you. So
Okay.
I will let these folks run with it. Turn the page. Well, I spent some time learning what best will work for you. 236. I'm gonna give you you can do 4. Okay. All right. You could do 4 through 10. But I would like you to pick one of those problems, except number 1 or number 4, to do long division on. Quick people. So 4 through 10, and I would like you to do long division on one of them. I suggest number 6. Because 4 and 5, Stormy, they're just simplifying monomials, and 6 through 10 are dividing.
Okay.
Again, I recommend you use long division on number 6. And maybe number 12. Oh, I didn't assign number 12. Okay, good. Okay. So I'm going to turn off the recording. The homework is 4 through 10, Jessica. And I'm going to stop the recording so I can work with Stormy on figuring out a fancy way of setting up synthetic division that will work. Once I get the mouse up again.
So we aren't doing any synthetic division here?
Yeah, it just says simplify, so you can choose what method to use.